Very good morning, children. In today's session, we are going to continue with Boolean logic. In today's session, we are going to understand basic logic gates, basic postulates of Boolean logic, the principle of duality, and the basic theorems of Boolean algebra logic, that is Boolean logic algebra. Okay, so this is what we are going to discuss in today's session. So, without much delay, let us get into the chapter concept. So the first topic that we are going to understand is basic logic gates. So before we get into the logic gates, first you have to understand what is a logic gate. A gate is a basic electronic circuit which operates on one or more signal to produce an output signal. It is an electronic circuit. Okay, it is a electronic circuit. So which will get one or more signal, that is high or low or whatever. Okay, it will receive one or more signal and it will produce the output signal. So that is what logic gate is. That is what gate is. Okay, so what are all the basic logic gates that are available? Those are all NOT gate, and then OR gate. Let us discuss one by one. The first one is NOT gate or inverter. We have already discussed about the functionality of NOT operator. So now we are just going to understand, you are actually going to understand only the symbolic representation of the same. In last week's session, we have already discussed the general functionality of NOT and OR operators. So in today's session, along with those operation, we are going to understand the symbolic representation of these operators. Okay, so because at the end of the session you will be asked to write the logic circuit for the given Boolean expression. At that time you should be able to write, you should be able to draw the logic circuit, right? Okay, so the first one is NOT gate. So NOT gate, it's nothing but NOT operator. Okay, so which will give you which will take only one input and produce only one output. Okay, and it will always the opposite of the input. If the input is 0, the output is 1. If the input is 1, the output is 0. So and this is your symbolic representation. This is how you have to draw the logic circuit. Okay, so that is, there is a triangle, the triangle, there is a bubble, that there is a in the point there is a bubble. Okay, so this is your input. Okay, x is a input. So when you give x as a input, x complement or x dash, this is your output. Okay, and this is your truth table. Okay, if x is 0, the output is 1. If x is 1, the output is 0. Okay, so this we have already discussed. The only thing is the symbolic representation. This diagram represent the NOT gate. The next one is OR gate. So OR gate, as we have already discussed, OR gate, it will take 2 or more input and it will produce only one output, right? Okay, so in the OR gate has 2 or more input signals but only one output signal. If any of the input signal is 1, then the output signal is high. If any one of the condition is satisfied, then the output is high. Okay, if all inputs are 0, then the output is 0. So that is the functionality of a OR operator. How to represent OR gate? And this is your representation. Okay, this is a 2 input OR gate. Okay, A and then B. So these two are inputs, right? Okay, and then this is your OR gate representation. Okay, and F is a output. So how to draw the truth table? So here A, B inputs. So there are 2 inputs. Abdina, there are 2 to the power of 2 combination, 4 different combinations, 0, 0, 1, 1, 0, 1, 0, 1, right? Okay, and then F is equal to A plus B. So 0 plus 0, 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. And this is your 3 input. Okay, this is your 3 input OR gate. So it will take 2 or more inputs. Okay, if there are 3 inputs, what will be the output? Okay, so what it says, if any of the input signal is high, okay, among A, B, C, if any one input is high, then the output is high. Okay, that is how you have to understand. Okay, if there are 3 inputs, there will be 8 different combination, that is 2 to the power of 3. So 2 into 2 into 2, which is 8. Okay, there will be 8 different combination. How to write it? So it is first 4041, 2021 and 2021, 0 1 0 1 and then 0 1, and then f is equal to a plus b plus c. So 0 0 0, there is 0. Okay, so when you look at the second line, the c is high, c value is high, so the output is high. Okay, so when you look at this, at least any one of the input is high, so the output is, it's always it's almost high all the time. Okay, so here what you have learned is the representation, the OR gate representation, the 3 input OR gate representation. The next one is AND gate. So this is your AND gate representation. AND gate, so AND gate also, it will take 2 or more input signal and produce only one output signal. Okay, so when all inputs are high, only when all the conditions are satisfied, the output is high. Okay, otherwise the output is 0 only. So this is your 2 input AND gate. Okay, so A, B, there are 2 inputs. This is your AND gate representation, and F is a output. So AND gate, it will be represented with a dot symbol. So A dot B. So this is your truth table. Okay, only when all the inputs are high, the output is high. And this is your 3 input AND gate. So in the 3 input AND gate, okay, so you are giving all the 3 A, B, C, and when there is 3 input, there are 8 different combination. When all inputs are high, the output is high. Okay, so these are the basic logic gates, right? So the next topic is basic postulates of Boolean logic. What do you mean by basic postulates? Basic postulates are nothing but basic theorems or fundamental laws. Okay, so the fundamental laws that are used to build a workable cohesive framework are known as basic postulates. That is, it is a basic theorems or basic laws. That's it. Okay, so that is called as basic postulates. Okay, for a Boolean logic, what are all the fundamental laws? So these are the one which we have already discussed. We are just restating one more time. If x not equal to 0, then x value is 1. Okay, because x can take the value either 0 or 1. So if x is not equal to 0, then it must be 1. If x is not equal to 1, then x must be 0. And then what are all the OR relation? What is the OR operations? 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, right? And then AND operation. Okay, when you have 2 inputs and there is an AND operation, what will be the output? And then complement rules, that is the NOT operator. 0 complement is 1, 1 complement is 0. Okay, so these 4 laws, these 4 theorems or laws are called as basic postulates of a Boolean logic. So next topic that we are going to understand is principle of duality. It is a very interesting principle. Okay, so this states that, and the duality principle states that starting with a Boolean relation, another Boolean relation can be derived. That is, I am having a Boolean expression, some Boolean expression. From one expression, you will be able to derive another expression. So to derive another expression, you have to do these 3 steps. Okay, all the 3 steps you have to apply to the Boolean expression. What are the steps? That is, changing each OR operation with the AND sign, changing each AND sign with the OR sign, replacing each 0 by 1 and 1 by 0. When you apply all these operations, you will get a equivalent expression. Okay, that is, whatever the expression, I am having one expression. Okay, you will be able to get another expression, okay, valid expression, by applying all the 3 logics. For example, x plus y complement. So here I am having plus as a operator. So according to principle of duality, you have to replace or with and. So x plus y complement. Okay, from this I can derive another expression, xy, the whole complement. There is no change here. And then xy plus xy complement, some other expression. Okay, so x and y, there is a AND operation. Between that, you will be able to, you have to apply OR operation. So x plus y, and then plus should be replaced with the dot, and then here there is a AND operation, so again you have to replace it with a OR operation. Okay, so this is one expression. From this expression you are deriving another expression, right? Okay, so that is what the purpose of principle of duality, that is with the one expression, with one Boolean expression you will be able to derive another expression by applying all the three logics, okay, wherever applicable. Now look at this. So 0 plus 0 is equal to 0. Okay, sorry, it's supposed to be 0. Okay, so when you apply that, that is, this is a OR relation, one of the OR condition. Now you are replacing zeros with 1. Okay, 0 should be replaced with 1. So here 1 dot 1 is equal to 1. Okay, here also it should be 0. Okay, when you replace that it will become 1, and then 1 dot plus is replaced with 1. So 1 dot 1 is equal to 1. What is this? This is another valid relation depicting the AND operation. Okay, this is called as principle of duality. Okay, you will be given expression and then you will be asked to write the duality of the same. So at that time you have to apply all the three rules and then you will get another expression. This is called as principle of duality, right?